Hi, in this video I'm going to show you how to build a basic circuit in a breadboard. So for this example, we're going to use the circuit depicted over here, and we're going to build this in this breadboard. And for that, I have got a bunch of wires, a red and a black wire for my power supply, as well as the 1K, the 2K, and the 10K resistors that are indicated in the circuit. So let's begin by connecting my power supply. So I have a red wire which will be connected to the red line in the breadboard, black wire for the ground, right? So by convention we know that red means positive and black means ground. So I'm going to connect this into the positive side of my breadboard and ground to the negative side. Now I'm going to make the first connection, the wire coming from the plus side to my first resistor. And to do that, I just simply pick one of my wires, right? I connect from the positive 12 to any row that I choose in my breadboard. Now, remember that in a breadboard, the vertical rows are connected with each other and the horizontal rows are not. What it means is that, for example, all the dots in row number 11 form a common node, and whatever I connect into row 11 is going to be connected to this 12-volt supply. Okay, so I'm going to connect my 1K resistor. So I pick it, right, and connect. Remember, everything that is connected into row number 11 is going to be connected to plus 12 volts. Now, as you can see, the 1K, the 10K, and the 2K resistors are connected into a common node, right? All of them go to the same place. What it means is that I connect the other leg of my 1K resistor to any row of my choosing, in this case, row number 18. And everything else I connect to row number 18 is going to be connected to this common node. Okay? So in this case, I pick my 10K resistor. I connect to the common node, and I connect the other leg of my 10K resistor to any other node in the bottom side of the breadboard. Remember that the middle section separates the rows in the upper and the bottom side. What it means is that, for example, row number 18 in the upper side is not connected to row number 18 in the bottom side. Okay? So now I want to close this connection for my 10K resistor. I want to connect this wire. Okay? So I pick one of my wires. I connect from the ground node of the 10K resistor, right? And I go back to the general ground section. Okay? Now I want to connect my 2K resistor, right? As you can see, everything is connected to a single node. What it means is that I am free to connect one leg of my 2K resistor to this node, number 18, right? And I have two options. Either I connect the other leg of the 2K resistor to the common node of the 10K and ground, right? By connecting here. Or in this case, since I have a lot of wires remaining, I can make my circuit easier to handle and connect to any other node, right? And then from this other node, I can connect a wire to the ground node. Okay, so this completes that circuit. Now I'm going to show how to get the measurements of I1, I2, and I3. First, I provide power to my circuit. Well, actually, you know what? Before providing power, it's usually safer to finish all the connections. So in order to measure I1, remember that I have to do a measurement in series with a resistor. So I need to open a loop between the 1K resistor and the common node and close that loop using my multimeter. So I unplug the 1K resistor, I connect it somewhere else, and now I get two wires, one coming from the node where I connected my resistor, and the other one closing the loop. I connect to the common node, in this case node number 18, and I will close the loop by connecting my multimeter between these two terminals. Okay, now I am ready to provide power to my circuit. I turn on my power supply. I double check that I'm getting 12 volts, and now I do the measurement. I adjust my multimeter by selecting milliamps because this is a circuit with high value resistors and a low voltage, so I'm going to be measuring milliamps, right? So now I perform my measurement. I connect my terminals to the terminals in the circuit, and I got my first reading. This is a value of I1. Now, if I want to measure I2, I perform a similar procedure. First, I unplug my two terminals. Next, I plug back the 1K resistor to the common node. And now I want to open the loop between the common node and the 2K resistor. What it means is that I will unplug my 2K resistor, I will connect it somewhere else, and I will perform the same operation. I connect a wire from my common node, another wire coming from the 2K resistor, and I close the loop by connecting the terminals of my multimeter. And this is the reading for I2. I will do something similar for I3. Actually, I can leave this wire where it is because I don't really need to move it. I just remove the wire from the 2K resistor. I connect back the 2K resistor, and I connect the 10K resistor to any other node in the breadboard. I connect my measuring wire, right? Or my wire to perform the measurements. And I close this loop by connecting the terminals of my multimeter. And now I'm getting my measurement for I3. Now you may be wondering why I'm getting a negative measurement. Well, it's simple because I'm connecting my negative lead into the common node. So if I change the directions, if I connect the positive lead into the common node and the negative to the 10K resistor, I will get a value with a positive sign. Okay, this is how easy it is to build a circuit in a breadboard and how to perform the current measurements. Hope you enjoyed this video. Thank you.